All right, welcome back to our part 2 of our Why NSX series. The first part, we discussed what the physical fabric resembles in most of the environments today that we encounter, whether it be customers that are coming from a legacy multi-tiered access distribution and core, and they're moving to a spine leaf architecture and trying to decide on how that will work, or customers that already have a spine leaf architecture using a variety of vendors out there, some with some proprietary entanglements and some with more traditional and standardized use of L3 and L2 servicing, such as just multi-protocol BGP, EVPN with VXLAN. Obviously, that's a jumble of words that we're going to try to avoid using throughout much of this discussion, but it needs to be said that these persist in the physical fabric today. What we're going to show, though, is that we can provide that same sourcing and endpoint resolution and servicing of workflows within the NSX virtual networking that we will provide within VCF private clouds, VMware Cloud Foundation. And we're going to use that VCF networking to simplify how we communicate our workload, how we can provide secure servicing of those workloads. Those will be in later videos. This Lightboard is really going to give a 10,000, 5,000 foot view, if you will, of just VCF networking in general. And then we'll go into more discriminate discussion at later videos. So for this first one here, let's talk a little bit about what, of course, you have today. You have your physical fabric. And we're going to draw this down here. We're going to flip it on its head, because in the first one we concentrated and focused a bit more on it, so we drew it at the top, which is generally the way you see most diagrams. For ourselves, since the majority of the smart connectivity is going to be performed in the virtual infrastructure, we're going to flip it on its head. We're going to place the physical fabric on the downside here. Now, and the only reason why I'm making note of that is the fact that technically, the virtual network is the stub network. It is the endpoint, right? We don't wish to be a transit between two different physical fabrics per se. We might be a transit network, though, from one site to another site, and we're going to discuss that in greater detail at other Lightboards. But this one will at least make note of the fact that we can provide that, obviously, with the aid of the physical network's interconnectivity between the sites and possibly some of our hyperscaler partner cloud environments. Therefore, physical fabric, and it can have anything, but we already made note of the fact that it's probably going to have that leaf spine architecture with a VXLAN style fabric with a mesh of protocols in order to service endpoints as well as to provide some extension. But what we're going to discuss is the fact that instead of the way you would normally accommodate the iterative process of managing VLANs that are injected into the DV port groups of the virtual distributed switch of vSphere, so this green line will represent vSphere. We don't require this iteration of manicuring VLANs in the top of the rack switching and injecting them and providing their mapping into VXLAN, whether it's an automated or it's some type of declarative model in the physical fabric. You still would have to have those VLANs consistently mapped to the TORs, to the respective interfaces of the switch interfaces, to the respective interfaces, of course, of the ESXi host and the clusters that will be in the vSphere infrastructure. Instead, in our private cloud infrastructure, we're going to see that we require a singular IP connection. Obviously, it'll probably be represented as a VLAN, but it's be a single IP connection that will be used as our tunneling service, and that we will incorporate that tunneling service across all of our ESXi host and the clusters that are going to be part of the NSX virtual network infrastructure. Further, there will be this edge ideal, and we're going to talk a bit more about that, but there'll be this edge ideal, and we're going to talk about how that is. So when you deploy NSX, let's actually, before we get to that, when you deploy NSX, all right, in deploying of NSX is going to provide a series of services so that we're aware of what it is. So NSX is going to provide a series of services. And these series of services are going to be found within our virtual distributed switch. This virtual distributed switch is a component of the VM kernel of vSphere. So everything happens at high performance rates inside of the kernel, and we utilize offloads of the hardware of the server itself, as well as the NICs that are incorporated into the interaction and communication between the infrastructure and the physical switching. So therefore, we get essentially hardware-based communication off of our host, which gives us essentially near-line rate performance with stateful firewalling, mind you. So that's interesting to note. So within this virtual distributed switch, we have our distributed switching, we have our distributed routing, and we're also going to see in later discussions our discussion of distributed firewalling, so that we incorporate the values of essentially what you would have to utilize within those service leaves that we discussed in the first one, where you would have dangled off of it a series of highly available appliances for load balancing, firewalling, deep packet inspection functionality, taps that you would have to essentially manicure and manage across your infrastructure in order to pull and extract knowledge of your workflows and possibly malicious activity that's occurring throughout the virtual infrastructure. We're going to see that all of this is incorporated into NSX, and this firewall here will also represent essentially layer 3 and 4 as far as the circuit layer stateful firewalling, but the contextual services in layer 7, identifying it, as well as, of course, all of the deep packet processing services for detecting malicious activity within that virtual infrastructure. So that is about as much as we're going to discuss about security right now, although we'll just offhandedly manage and discuss it a bit more. But I wanted to make sure you're aware that these are inherent in the NSX servicing in the kernel, providing that high-performance network I/O communication. So we stated it, when you deploy NSX, you essentially will inject into the vSphere host the licensed serviceability of NSX servicing, and this can be done in a non-disruptive manner. All right, so that NSX is now fully available across the environment, but now we need to begin instrumenting its operational servicing. If you're using the SDDC manager, the software-defined data center manager of VCF, it's actually going to provide an automation of all of what I'm about to discuss as far as setting up NSX servicing within your management domain and all of your workload domains of a VMware Cloud Foundation private cloud. So that's important to note. So even though we're discussing these as if they're a series of iterative processes that you would have to do, you would do so either through the NSX console if you hadn't deployed the entire VCF structure of services, which allows you the automated routines that SDDC Manager will essentially allot and save you tons of time, or you can go through NSX management and simply iterate in a process using the wizards within NSX to deploy what we are about to discuss. So as I stated before, you're going to inject the NSX functionality into a series of hosts. You're going to state that you want those hosts to become what we call transport nodes. In other words, those ESXi hosts that are going to be defined based upon you picking out vSphere clusters. And you're going to see that you're going to have a very simple virtual network that NSX is going to provide. So I don't want to go through too much of the mechanics, but I wanted you to see that it's very simple to set up. So when we talk about why NSX, it's extremely simple to set up. It's not that difficult, and it's non-disruptive. So that those series of hosts, if we so desire, if we're just doing NSX on itself, it doesn't actually disrupt what it's currently performing as far as compute and storage servicing of any of the current workloads. If it's a VCF environment, our current way of deploying VCF would require you to set up a greenfield environment and then start a process of iterating all of your clusters through a serial deployment of your environment to do so. But again, it's all fully automated in the way SDDC Manager would do it. So again, the YNSX, just giving you both sides of that story. So with NSX, we would then set up those clusters, and then we would essentially utilize a TEP, a tunneling endpoint. And I'm putting them down here, this little pink dot, to represent the kernel element that is in every ESXi host of every cluster spread across your series of racks. And this particular endpoint graphic that I'm drawing in here represents these features inside of the distributed switch, so that you are aware that all of that is occurring inside of it. Further, you would then set up, all right, in your environment, sorry about that, you would then set up in your environment your edge, your gateway services. Now, we don't need to worry too much about nomenclature, but we nickname that T0 because it's the first tier. And of course, in compute, 0 always represents 1. Okay, so tier 0, which is essentially our distributed edge, if you will, because it's distributed throughout these. So in other words, each of these tunneling endpoints are aware of how to get to the edge, but the edge itself is defined at a locality for its physical interaction with the physical infrastructure. And this is done through a variety of routed communication or static routing communication. So automated routing with obviously BGP or OSPF, mostly external BGP, or with static routing if you so desire. And you can use two different flavors of setup for that external routing. You could use it through an ECMP so that it's a scaled environment, or you can use it through an active standby if you had certain stateful functions that required the use of a singular exit and entrance point for some of your workloads. But the T0 is an abstraction. It's not an implementation of a single node per se. It's a single ideal of how edge is serviced within the NSX virtual network. So that's an important ideal. Now, it's a simple ideal, though. That's the whole point. This edge in itself presents our spine, if you will, because we can scale this to whatever we need. Do we need multiple active standby? Do we need a singular ECMP spine for our north-south I/O capability needs? Whatever that ratio is to north-south, depending upon the I/O bandwidth that's required. And then we can go ahead and spread that across a series of edge nodes. And then those edge nodes are performing at 10, 25, and 40 gigabit or higher communication link. Although, in order to attain some of those higher ones, I just want to make certain that we're aware that those would be more of our bare metal edge nodes, because we have two form factors. We can use bare metal or we can use virtual. But the point being is that we give you the characteristic value of either using the vSphere virtual environment or a bare metal system in order to attain higher I/O and packet per second ratios whenever necessary. Once again, YNSX gives us that ability to essentially craft a spine environment. And I'm going to use the spine leaf analogy much like we do down here, so that you have a spine that you scale so that if you have a greater fan out of I/O needs to the TORs, depending upon the I/O nature of the communication within the internal fabric itself, and whatever needs to, of course, correspondingly come into the fabric and exit the fabric, the spine can suit its needs. And in a leaf spine architecture, adding additional spines actually adds I/O capacity, whereas the old three-tiered access distribution and core, essentially you had two. And although there was some manner of stating there was an offloading of 50 and 50, it essentially was really 100% of one was the totality you could count on. In a leaf spine architecture, you actually get nearly 100% of each one, minus how much you would have to repeat for intersection and communication within the TORs. Same thing here. Our spine essentially allows a greater I/O on a north-south basis for communication. Our leaves are essentially the individual host. Now again, this is more of an analogy that I use on my own. This isn't part of our formal documentation, but the idea of this analogy is meant to address any misunderstanding of how our architecture operates, so that you're aware that we can scale the spine so that we get that north-south interaction of virtual high-performant interaction of connectivity from the VLAN-backed world to our tunneled endpoint services of our virtual network. And then the leaves themselves, we simply do exactly like you would with your physical network, and we iterate additional leaves, ESXi host, that have the embedded value of compute, possibly virtual storage if you wish to leverage it, and virtual networking with secure servicing. So that's pretty cool. That's our leaf spine architecture, if you will. And the logical interaction that you would use for segmentation, we are going to discuss just momentarily with our logical segmentation. So taking this now to the next step, we have our edge. Well, obviously, we still would like to have more than a single tier of routing. Why? Well, logical segregation of communication of virtual networks so that some virtual networks on some distributed network, we don't wish for their interaction to another. We have two methods of dissuading that to occur. One is our stateful firewall so that you can securely manicure what is permitted. Or you could simply say, listen, I just want to make certain that one tenant never communicates with another tenant, so we'll go ahead and use the concept of our second tier to assure that they're at least not virtually interacting. I can't say physically, but they're not virtually interacting with each other. And it's our tier one, so that each of these tier ones can be crafted as distributed components. Now, I don't have to draw additional things. This pink represents a series of dynamic elements that is occurring across the entire nature of how our virtual network operates. Again, the simplicity factor. The deployment of NSX is already going to give you, first and foremost, manageability of the entire infrastructure through a singular management dashboard interface. That's key. This can be across one site, and if I were to draw this on another site, I'd simply repeat and draw. Same thing. Secondly, the control plane. Notice I don't have to discuss that like down here. I would have to set out, how we would have to use, let's say, OSPF to provide interaction of all the switches and the spines and the leaves to make sure everybody can interact with each other. And I'd have to draw out how we are going to manicure the interaction of endpoint resolution and how I'd have to inject route servicing in there. And I would have to essentially draw 3 different control plane services in order to provide all of those characteristics and features. Whereas NSX, I simply deploy. Period. I'm done. I don't have to administer any of that. It just occurs because the control plane and the management plane are essentially 2 of the 3 elements that are a part of our NSX management architecture. We'll get to that in a moment. So the distributed routing, the edge routing, the injection of functionality within the vSphere infrastructure, and I'm essentially doing this in reverse order as far as the description, but normally I would do, of course, set up the NSX management capability, deploy my management. I deploy my transport nodes. I would deploy my edge, which are essentially specialized transport nodes that not only have themselves has a tunneling endpoint, but they also have the ability to now take the east-west communication and traverse it on a north-south so that I can have internal and external and ingress and egress communication into the virtual network through and pervasively on an east-west basis through each of the ESXi hosts that are using a tunneling endpoint for interaction for all my east-west communication. And then I have distributed routes that, although they're drawn here, they're essentially distributed here. So that if I have virtual workloads, okay, and I deploy, let's say, virtual workloads, okay, and my virtual workloads are deployed as such. Now, I know I drew 2 lines there, but there could be virtual workloads, let's say, here. I guess this was not drawn real well, but okay, on that line there, okay. Same thing here. My virtual networks, first and foremost, we refer to those as logical segments, or segments sometimes for short, but they are essentially the same L2 pervasive communication medium that a VLAN affords you inside of the physical fabric, except take note of one specific simplistic ideal here. I simply just craft the abstraction. I don't have to do any external mapping. I don't have to make sure my control plane protocols are automatically doing any of that. It just occurs because we don't have any of that extraneous concerns that a physical fabric has. When we create this L2 extension, if you recall, we created our transport nodes. Well, a key value of our transport nodes, and I don't usually mention it in the beginning because it makes more sense to do this so now, is this concept of a, if you will, of a transport zone. That wherever I have stated that a certain set of my ESXi and vSphere hosts are clustered and are going to create a continuity of communication through something we call a zone, this permits a simplistic L2 extension as well as L3 interaction on an east-west basis in an automated fashion throughout or pervasive of either a whole site, if I so deem that site to have a single zone of communication, so that I don't have to do any of this extraneous activity that the physical fabric would deem and require in order to manage and manipulate services in the same way. I simply just say they're all part of the same thing, it just now occurs. So when I create this segment, it just now gives me L2 pervasiveness for any workload that I allocate upon a host to be computed for its service, and therefore now that workload is forever a part of that environment unless I decide to move it. So again, simplicity, that's key. And it's consistent. I don't have to do anything different upon the craft and creation of any of these other segments. It just occurs. Consistency, simplicity, those are two key aspects of our private cloud. Scale. I can scale the functionality of that workload computation now to its fullest extent on every vSphere host. I don't have to concern myself with what iterative set of service needs are available to the physical switch fabric or the physical switch fabric is making available to the compute cycling. I just need that singular IP connection from my physical fabric to each of the hosts in each of my racks. Very simple servicing down here where I could set up this environment in a matter of hours across an entire data center. That's how simple this is. Now, assuming everything is racked and stacked and cabled, of course, but the logical nature of managing and manipulating what is required for us is nothing. It's barely nothing compared to what would normally have to be done on a native VXLAN, multi-protocol, BGP, EVPN fabric that you would have to essentially manicure those services and make certain that they are providing that control plane knowledge across an expanse of racks and services. Now I just need a singular IP connection. I really only need L3 from the fabric, maybe once in a while, depending on use cases that we'll get into in later discussions, where I might need an extension of L2 for some features. But mostly I need nothing but L3 and L3 between two sites to do the same thing that we just drawn out for this site. Or if I wish to extend this site into another site, again, I simply need L3 to provide L2 or L3 over it for virtual networking. In addition, to come back to one element that we discussed previously, the simplicity of our world of scaling it out so that we get opportunistic connectivity whenever two workloads are on a singular host. Now you're aware in vSphere, if I have two workloads on same DV port group, the same VLAN backed port group, if this was the old legacy style, they would be able to interact on the same host without ever having to, of course, traverse the physical fabric. But the problem is securing them, and now we'd have to do all kinds of newfangled things or inject agents into those workloads and have to manage those agents in order to get that. And even then, I'm only getting a little bit of the firewall functionality of whatever that agent can provide based upon the host firewall, which is not necessarily a means of true security because that part of the host is now part of the OS that's being attacked, and that's actually not good. What I would want is stateful secure servicing. The desire to use opportunistic communication. And what I mean by opportunistic communication, where it means that if two workloads, let's say these are upon the same host, they could actually interact and provide secure servicing without ever having to leave that host. And if I had another virtual workload, let's say, that was on the same host. Oops. Always make sure you check your inks. All right. And let's say it's on another logical segment, so it has to route. I can also assure myself that I'm going to get stateful, secure L4 through L7 deep packet inspection, if I so desire, of these two workloads opportunistically switched and routed on the same host. Now I can enforce that through the use of various policies on the vSphere environment if I so desire, but the idea is that I get some opportunistic routing and switching on the same host just because of the nature of where workloads may land, or I can force them to garner that value if I so desire. And if I have, of course, that communication across the environment or within the same host, I also have the medium of using secure firewalling when it comes to the distributed routing. This is not a dumb pointer of directional communication. It actually has a series of very smart, capable service functions that we embed into our distributed routing within NSX today, therefore giving you the full complement of secure servicing as well as load balancing if you so desire, that we can either inject through load balancing of virtual appliances within the virtual infrastructure or using some of the native load balancing that is actually a part of NSX. Thereby you getting this virtual fabric of managed serviceability without having to manicure a very complex world within the physical fabric, reducing the amount of I/O so we get better scale, better capacity usage of the host, better capacity usage of the physical fabric. And most of all, too, this physical fabric really only now has 3 dependencies for us. 1, does it function? So in other words, it's just not broke. 2, does it give us the I/O value that we require? And 3, does the vendor still support it? Because obviously supportability from the appliance itself means that we need updates so that we can keep it within a secure compliance of whatever our policies are and whatever we have going forward as far as the nature of length of its use. So those 3 things are the easiest 3 things you can get from any appliance you purchase, regardless of whatever its utilitarian usage. And for our purposes, it reduces our desire, therefore, for anything other than just updates, refreshes of its software at specific intervals in order to accommodate whatever security compliance needs that are required. But we don't have to care so much about what feature functions it delivers, because we now get the iterative scale value across all of the infrastructure because we are now no longer dependent upon it. So we get hardware dependence, another key feature of our private cloud. So we get simplicity, we get simple availability because we get the L2 extension, we get disaster recovery services that we can manicure through abstractions in the virtual network, we get scalability as far as the total usage and consumption of all of our hosts without concern of the physical fabric, as well as extension throughout the data center for that same scale value, and we get full scale value of the I/O nature of the entire environment, inclusive of the infrastructure. And then we also get now, we're going to talk about in a later one, consumption ease, because these segments are nothing more than DV port groups. They are still one and the same that you are used to using for the past so many years since I think 2007 when vSphere 4 came out with the concept of a distributed virtual switch with DVPG, DV distributed virtual port groups. So you get that same logical segment management as opposed to having to manage and manicure that iterative services that we discussed in the first one. We got more to talk about. This has been Paul Mancuso for YNSX Part 2. I hope to see you in further videos that I'll make in the future. Thank you for watching this presentation. Have a good day.